Hello everyone. In this video, this is the fourth video in our series. In this video we are learning about the product rule, and the product rule is on page 21 of your note packet. So I'm going to explain that to you and then work the examples in your note packet. Okay? The product rule, we have a function h of x that is the product of two other functions, f of x and g of x. Right, so h of x is equal to f of x times g of x. Now, you might think that the derivative of h of x, denoted h prime of x, would just be equal to f prime of x times g prime of x. If only it was that simple. Okay, it's more complicated than that. One form of the derivative on the right-hand side can be written as the first function f of x times the derivative of the second function g of x. It's g prime of x. And then we add to that the second function g of x, and we multiply it by the derivative of the first function f of x, denoted as f prime of x. So this is one representation on the right-hand side of the derivative of f of x times g of x. Okay? Now, in math, you know that when you add two numbers, you can switch the order of addition, right? You know that 5 plus 3 is equal to 3 plus 5, right? So we can, another way to express the derivative on the right-hand side is to switch the order of addition, right? Put the second term, g of x times f prime of x first, and then this first product, f of x times g prime of x, second. So this is the second representation of the derivative of this product up here of two functions. Well, also in math, you know that you can, the product of two numbers can be switched. You know that 6 times 2 is the same as 2 times 6. So we can switch the order of multiplication, right, in one or both of these terms to get yet another representation for the derivative of the product of f of x and g of x. And when we switch the order of multiplication in these two terms, we have f prime of x times g of x and g prime of x times f of x. So these are three possible representations, switching the order of addition and multiplication of the derivative of the right-hand side, the product of two functions, f of x and g of x. In this semester, I'm going to be working mostly with the first representation, f of x times g prime of x plus g of x times f prime of x. And to help me remember this representation, okay, I think of f of x times g of x, right, as the product of the first function times the second function. So big F stands for the first function f of x, and big S, that's not a 5, that stands for the second function g of x. Then substituting for f of x and g of x and g prime of x and f prime of x in this first representation, I have for the derivative on the right-hand side the first function times the derivative of the second function, which I denote with s prime, and then we add to that the second function g of x and multiply it by the derivative of the first function f prime of x. So we have the first function f times the derivative of the second function, denoted with s prime, plus the second function times the derivative of the first function, denoted f prime. And so this is the representation, okay? This first representation is the one I'm going to be working with a lot this semester. But when you go to the Math Outreach or the Math Learning Center, right, whoever you get help from might use the second representation or the third representation in applying the product rule. And so you shouldn't be shocked if somebody uses a different representation, the second or the third representation in applying the product rule in calculating a derivative. Okay? So let's work some examples in your note packet on page 21. In the first example, we have h of x is equal to 3x plus 2 times 5x minus 1. Now we could find the derivative of this function by FOILing these two binomials and then using the sum and difference rule. But we're really here to demonstrate application of the product rule. So my first function in this example is, on the right hand side, in this example, is what's in parentheses, 3x plus 2, in the first set of parentheses. And the second function is what's in the second set of parentheses, 5x minus 1. So to find the derivative of h of x, which we denote with h prime of x, using the first representation of the product rule up here, I take the first function, 3x plus 2, and I multiply it by the derivative of the second function. Well, second function is 5x minus 1, and the derivative of 5x, you know, was 5, and the derivative of minus 1, the constant, you know, is 0. So then I add to that the second function, 5x minus 1, and I multiply that by the derivative of the first function. Well, the derivative of 3x is 3, and the derivative of plus 2, the constant, you know, is 0. And so h prime of x, right, the derivative of this function up here, is equal to 3x plus 2 times 5 plus 5x minus 1 times 3. Now you could simplify that if you want, but on an exam, unless we're doing some kind of word problem, right, you would not have to simplify that. Okay? We just want to know, do you know how to differentiate this function using the product rule? All right. In the next example, so I'm going to erase these other two representations of the product rule, since I won't be using them, and I'll just be using the first representation in our examples. In the next example, we have g of x is equal to x to the 8th plus 5x times x cubed minus 6x plus 1. Now notice that g of x is on the left-hand side on this example, so its role has changed from our definition of the product rule up here. But we have the product of two functions on the right-hand side. So this in parentheses is the first function, and this in parentheses here is the second function. And so the derivative of g of x is equal to the first function times the derivative of the second, plus the second times the derivative of the first. Okay? That's what that's telling us. So let's find that derivative. So the derivative of g of x is denoted g prime of x. And using the first form of the product rule, we have the first function, x to the 8th plus 5x, times the derivative of the second function. Right? Well, the second function is what's in parentheses here. The derivative of x cubed by the power rule is 3x squared. The derivative minus 6x is minus 6. And the derivative of the constant plus 1, you know, is 0. So then we add to that the second function, which is x cubed minus 6x plus 1. And we multiply the second function by the derivative of the first function. Well, the derivative All right, this in parentheses here is the first function. The derivative x to the 8th is 8 times x to the 7th, and the derivative 5x is 5. So this is the derivative of g of x, okay? G prime of x is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function on the right-hand side. And we're done. You don't have to simplify. In the next example, we have y is equal to 5x times e to the x. Well, that's the product of two functions on the right-hand side. 5x is the first function, e to the x is the second function. So the derivative of this function, which we denote with y prime on the left-hand side, using this form of the product rule on the right-hand side, we have the first function 5x times the derivative of the second function. Well, the second function is e to the x. What's the derivative of e to the x? E to the x. And then we add to that the second function, e to the x, and we multiply that times the derivative of the first function. And the derivative, the 5x is the first function, and the derivative of 5x is 5. And you don't have to simplify. So, the derivative of y equals 5x e to the x. Right? We denote the derivative of y with y prime, and the derivative of 5x e to the x is 5x e to the x plus e to the x times 5. Okay? So we're just using this first form of the product rule, okay, over and over again. First function times the derivative of the second function plus the second function times the derivative of the first function. In the fourth example, we have h of x is equal to x cubed times e to the x to the 9th minus 2 power. So that's a product of two functions. X cubed is the first function. E to the x to the 9th minus 2 is the second function. Right? So the derivative h prime of x, again, first function times the derivative of the second, right? That's what s prime means, the derivative of the second function, plus the second function times the derivative of the first function. That's what f prime means, derivative of the first function. So h prime of x, using this form of the product rule, is equal to the first function x cubed times the derivative of the second function. Well, the derivative e to the x to the 9th minus 2, you know by the chain rule, is equal to, right, the derivative of e to the x to the 9th minus 2 is itself e raised to the x to the 9th minus 2. And then we got, by the chain rule, we got to multiply that by the derivative of the exponent. And the derivative of x to the 9th is 9 times x to the 8th by the power rule. And the derivative of the constant minus 2, you know, is 0. Now we got to add to that the second function times the product of the first function. Well, the second function is e raised to the x to the 9th minus 2 power, and then we multiply that by the derivative of the first function. First function's x cubed, and the derivative of x cubed is 3x squared by the power rule. And we're done. First times the derivative of the second, plus the second times the derivative of the first. In the next example, we have f of x is equal to x times the natural log of x. So that's a product of two functions. The first function is x. The second function is the natural log of x. So using this form of the product rule, f prime of x is equal to the first function x times the derivative of the natural log of x. And you know the derivative of natural log of x is 1 over x. And then we add to that the second function, the natural log of x, and multiply it by the derivative of the first function, and the derivative of x is just 1. So you could stop right there, or you can clean this up a little bit. And so you can either leave your answer like this, or you can clean it up. And if you clean it up, x times 1 over x is just 1, right? The x's cancel. And log x times 1 is just log x. Either would be acceptable on an exam. Okay? And then lastly, example number 6. The last example for the product rule. We have y is equal to 7 to the x power times the natural log of 6x plus 10. So this is on the right hand side, this is a product of two functions. 7x is the first function. The natural log of 6x plus 10 is the second function. And so using this representation of the product rule, the derivative of y, which we denote with y prime, is equal to the first function, 7 to the x, times the derivative of the second function. Well, second function is the natural log of 6x plus 10, and to differentiate that, we have to use the chain rule for the natural log function. And so, what goes using the chain rule for the natural log function? What's in parentheses goes in the denominator, and then what goes in the numerator here is the derivative of what's inside the parentheses, right, from our previous video. Well, the derivative of 6x is 6, and the derivative plus 10, the constant is 0, so we just have 6 in the numerator. Right? The derivative of the denominator here, 6x plus 10, is just equal to 6. And now we have to add to that the second function on the right-hand side up here, which is the natural log of 6x plus 10, and then we have to multiply that by the derivative of the first function, 7 to x, right? This is an exponential function, not a power function. And the derivative of this exponential function is the natural log of 7 times the exponential 7 to the x. And we're done. The derivative of y equals 7 to the x times the natural log of 6x plus 10 is all this. Y prime is equal to all this on the right-hand side. And we're done. We have successfully found the derivative of this function up here using this first form of the product rule. So this ends the lecture on the product rule, and in the next video, we'll be talking about the quotient rule.